In this section, we will be working with application problems which involve and require us to solve equations. In this first example, we have a formula which gives the target heart rate in beats per minute for a person who is A years of age. And we're asked to determine the age of a person whose target heart rate is 135 beats per minute. Now, the first thing we want to do is sort out the given information and the goal of the problem. So I'm going to start with the goal this time. The goal is to determine the age of the person whose target heart rate is 135 beats per minute. So I'm just going to write that down here. To determine the age of a person when the target heart rate is 135 beats per minute. Okay? Going back to the given information in this case is going to be the formula. You are given the formula that you need to use. So I'm going to copy that down. T equals 0.7 times 220 minus A. And you always want to write down what each letter represents. You have to know what the variables are. So in this case, T is equal to the target heart rate in beats per minute. And A is the person's age in years. All right, so moving over to the goal, the question asked is to determine the age when the target heart rate is 135 beats per minute. So going back to these variables, you need to determine the age. So determine A when the target heart rate, that's T, is 135 beats per minute. All right? This will help you form your strategy. So your strategy is to use the equation you want to determine A when T is 135 beats per minute. So you are going to solve for A when T is 135. That's what you're going to do. So coming down here, actually working this out, replacing T with 135, we have 135 equals 0.7 times 220 minus A. Solving this for A. Your first step is to distribute the 0.7. You want to remove the parentheses. So you have 135 equals 0.7 times 220. You may need to use your calculator for this one. It comes out to 154 minus 0.7 times A is just 0.7A. Now that the parentheses are gone, you need to solve for A. So subtract 154 from both sides. This gives you negative 19 on the left. 154 minus 154, that is 0. So I'm just going to cross it out and copy down the negative 0.7A. Now you still need to isolate A. So I'm going to divide both sides by negative 0.7. Divide by negative 0.7. On the right, negative 0.7 divided by negative 0.7, that'll give you 1. So simplifying there, you have on the right-hand side just A. It is isolated. On the left-hand side, negative 19 divided by negative 0.7 gives you 27.14, a long old decimal after that. So thinking back to what A actually represents, A is the age, so it really would make sense to round to the nearest whole number. So I'm just going to say A is about 27 years. And because we did do some rounding, I'm going to change this equal sign to approximately equal to. A is about equal to 27 years. That makes sense. So I'm going to make a little note here. I did do some rounding there. All right, so we have our answer. Now we need to check and make sure that mathematically it works and that it makes sense. So rewriting this equation, we have 135 equals 0.7 times 220 minus, instead of A, I'm going to replace it with our answer, 27. And then we just want to make sure it works out. So 135 equals, multiplying both sides, multiplying in here by the 0.7. 0.7 times 220, that's 154. Minus 0.7 times 27 gives us 18.9. So 135 equals 154 minus 18.9. That gives us 135.1. Now looking at these, 135 is not really equal to 135.1. But remember, we did some rounding here. When we came up with the 27, we actually had a decimal that we rounded to the nearest whole number. So that rounding will affect our check. I'm just going to write down here, rounding error. Looking at this, they're about equal. They're close. The difference, this 0.1, is due to rounding errors. So our answer still checks. Our final result, writing it as a complete sentence, a person who is about 27 years of age will have a target heart rate of 135 beats per minute.